Now, TCP and UDP, you're going to hear a lot about these two protocols in networking, but what's the difference? When would they be used? And how do we analyze them? Now, there's a lot that we could go over in these two protocols, but just to keep it simple, oftentimes the thing that you're going to need to remember for that certification or that interview that you're trying to ace is that TCP, or the Transmission Control Protocol, that's a connection-oriented protocol. And the User Datagram Protocol, UDP, is connectionless. Well, what does that really mean, and why do I care? Well, let's get into it in the packets so we can really see at the packet level what the difference is. So first of all, you can see here I have a couple of packets here. This is just DNS. Here's my DNS conversation. And then after that, I start up with a TCP stream. So let's go ahead and take a look at the DNS first of all. Now, if I come down here, I can see I got my layer 2 stuff, that's Ethernet. Then I got my layer 3 stuff, so layer 2 Ethernet, layer 3 IP, and then layer 4 I'm sitting in the user datagram protocol. So just clicking this protocol header over here on the right, you can see the associated bytes that are highlighted. And really, UDP is a very simple protocol, and that's why an application would use it when they don't need that layer 4 protocol to do a lot of thinking. UDP is very efficient. It's 2 ports. If we expand this out, source port, destination port, length, checksum. That's it. So quick delivery. We're not worried about whether the traffic got there or not. We're not worried about congestion control or how fast we're transmitting. We just let this packet go, hope it gets to the other side, and if we get a response, great. So here we can see a very common application or service, you could say, that uses UDP, and that's DNS. So very simple. We send our DNS request over UDP, and we wait for our reply to come back, and there we go. Very simple. There's no connection here. There's no protocol set up. Very simple. But that doesn't mean that UDP is just a bad protocol that nothing should ever use. Obviously, we're running DNS over it. And as a matter of fact, right now, you're likely watching this very video over UDP. And that's because UDP is also being used by other applications that are upstairs that have a lot of retransmission smarts and other types of data recovery features built in. For example, Quick. So Quick sits on top of UDP, simple 8-byte header, in order to be able to get into that kernel on the other side and just make a simple use of that stack. Okay, so UDP, connectionless, very simple, only 8 bytes in the header, just a source, destination, length, and checksum, and that's it. Now let's flip to TCP. A whole lot more is going on under the hood with TCP. And it's a whole lot more than just that one certification answer. It's a connection-oriented protocol. While that's true, let's take a look at how much is going on with TCP. So here we can see a simple TCP connection. Let's go back to our packets. So here we have a TCP SYN, SYNAC, ACK, 3-way handshake. Now, why do we need these 3 packets? Well, TCP, unlike UDP, is stateful. And what that means, it maintains a state on each end. Each end is aware of this connection. It dedicates resource to it. And there's a lot of things that happen on each endpoint, more than just a simple send and receive. So for example, when we establish a connection, take a look at that SYN, we're not just opening a port, but we're also dedicating other resources to this connection. So for example, we're beginning to count our sequence numbers. We have a TCP window, which is dedicated resource to be able to receive TCP data. And also we can see the other options that a lot of times we'll talk about in this channel, some of the options that are exchanged in that handshake. Now on the opposite side as well, we have port numbers, sequence and acknowledgement numbers. So data is being sent, data is being acknowledged. And then we can see also window size and other options as well. But TCP is way more than just a handshake. Every single byte that I transmit is tracked, if you will, by something that I call a sequence number. If I send you 100 bytes, you're going to acknowledge it and let me know that you got each one of those 100 bytes. If something was missed, you can let me know by that acknowledgement number. I can analyze it, and then I can retransmit any missing data. Another huge thing that makes TCP different than UDP is also congestion control. What this means is I don't want to send data so fast that I actually cause my own congestion on the network and basically muscle everyone else out of the way and cause my own packet loss, which would make me need to retransmit. Remember that TCP, it doesn't know what network it's going over. It could be that we're going across an ocean with very, very large amount of latency, or it could be that you're sitting right next door to me on the same switch with very low network latency. In addition to latency, also the amount of bandwidth that's available. So TCP is not aware of any of those things when it begins to transmit. So in many cases, what TCP will do is it will be conservative when it begins to transmit. It'll go through something called slow start. As data successfully makes it to the other side and acknowledgements come back, it will gradually increase the amount of data that it's putting out on the wire as successful acknowledgements come back. So that's a whole other facet of TCP that we need to think about that makes it different than UDP, congestion control. And that's where TCP will limit how much data it puts out on the wire and gradually increase the amount as it successfully is able to send data to the other side. Now, there's a whole lot of algorithms that control that, but let's just leave it at that for now. Now, at the end of a TCP connection, we have to tear the connection down. So what makes that happen? Well, two ways. So we can either fin the connection to tear it down, or we can send a reset in order to tear down the TCP connection. But either way, eventually, we don't want that TCP connection to live on forever. So TCP being stateful, both sides are going to dedicate resource to that connection for as long as it's alive. That's the reason why we don't want TCP connections to run on forever, because both sides are going to maintain that state. Okay, so whoa. We just talked about a lot of things, but let's just keep this very simple. What's the difference between TCP and UDP? Again, connection-oriented, connectionless. UDP, best effort. It will transmit and hope for the best. It does not resend data, and it does not do any kind of congestion control. TCP. TCP is connection-oriented. It first has to establish that three-way handshake. It maintains state. It tracks every single byte that's sent in order to retransmit any missing data. And it also implements congestion control so it doesn't overwhelm the network by being too aggressive by sending. So I hope this video was useful to you in understanding the difference between these two very core protocols at the transport layer, TCP and UDP. Thanks for stopping by. I'll see you again.